Alright, so continuing from the last video, we're going to take a look at Riemann's sums as rectangles, but this time from the left-hand side. So you'll see questions say the lowest sum, inscribe, or left approximation. All of those mean the same thing, finding the area of a curve using rectangles from the left. So step 1, follow all the steps for the right approximation, but in step 4, instead of using the x values from the right, use the values from the left. Okay, so it's pretty much the same thing we did in the previous video, only instead of using the values from the right, we're using values from the left. This is a listening check. Go ahead and color in this entire paragraph. Color in this entire paragraph. Alright, so first step again was to draw a graph representation. So we're going to go ahead and do that. And we're going to do 4 rectangles like we did in the previous video, just because I want to compare the different values we get. Alright, so again, you're graphing x squared plus 2 between 1 and 3 on the x-axis and finding the area of rectangles. So splitting it into 4 rectangles once again. So half of that would be 1 plus 3 is 4, divided by 2 is 2. 1 plus 2 is 3, divided by 2 is 3 halves. 2 plus 3 is 5, divided by 2 is 5 over 2. Because you add them together and divide by 2 to find the middle. Alright, once you've done that, the base is going to be a half, just like it was before. And then the height is this way, it's different. So instead of using the right, we're using from the left. So you start from the left, you draw a rectangle left to the top, draw a rectangle left to the top, draw a rectangle left to the top, draw a rectangle. So this time you can see that now we have spaces underneath the curve left over. So this is going to be an underestimation, whereas before on the one from the right, it was an overestimation. So you can see our area is going to be off a little bit. It's going to be a little bit less than it should be. Alright, so let's find the area of each rectangle. Remember, area of rectangle is base times height. This is a listening check. Put a box around lowest sum, inscribe left approximation, and color it in. So again, the sum, sigma notation just means sum. So the sum of all 4 rectangles is the area of the first rectangle plus the area of the second rectangle plus the area of the third rectangle plus the area of the fourth rectangle. To find the area of a rectangle, it's base times height. We already have the base, so now we need the height. Now remember, the height is from the left-hand side. So the base is a half, and then we need to work out the height. So from the left-hand side, we're going to use 1. So where you see x is equal to 1, you're going to plug it into the function and see what value you get. So if I plug in 1, I'm going to get 1 squared, which is 1 plus 2, which is 3. Alright, for the second rectangle, I'm just going to correct the height is 3 there. For the second rectangle, again, we're doing from the left, so that's f of 3 over 2, so we're going to plug it in squared. It's going to be 9 over 4 plus 2. Make the denominators the same, so multiply by 4. Do it at the bottom, do it at the top. 9 plus 8 is going to be 17 over 4. The height for the third one is going to be the left one, which is 2. So the height from the left, which is 2. So 2 squared is 4, plus 2 is 6. And then finally, the fourth rectangle, the value on the left-hand side for the height is 5 over 2. So we're going to square that, which is 25 over 4, plus the 2. Make the denominators the same so we can add them. So it's missing a 4, put it at the top. So 25 plus 8, which is 33 over 4. So all of these are the height of each of the rectangles. Alright, so the area is base times height. So we already did the first rectangle, and I can do the second one. The height is 17 over 4, the base is a half. The third one, the height is 6, the base is a half. And the fourth one, the base is a half, and the height is 33 over 4. Alright, so let's again factor out a half, because there's a half in everything, which just leaves the heights added together. So 3 plus 17 over 4 plus 6 plus 33 over 4. Let's make the denominators the same so we can combine them. So we're going to make all the denominators 4. If you do it to the bottom, do it to the top. So that's going to give us 3 times 4, which is going to be 12, plus 17 plus 24 plus 33 over 4. Adding all of those up together, we're going to get 86 over 4. I multiply those two fractions, multiply numerator 86, multiply denominator 8. Simplify by 2, you're going to get 43 over 4, which is, if you put in the calculator, 10.75. So we can see this is smaller, it's a smaller value than we had before because it's an under approximation. So we had 14.75 before. Alright, so let's make a general formula so that we don't have to do this the entire time. The base of both whether you're doing left or right is going to be b minus a over n, where n is the number of rectangles, a is the left endpoint, b is the right endpoint. So I'm going to show you actually where this comes from. Let me just draw a graph and let's label these things so you can see what it is. So let's call the first point A, the second one B. If we were to use this shortcut before, let's say we had, in our previous examples, we had 4 rectangles and it went from 3 to 1. So 3 minus 1 is 2, divided by 4 would simplify to 1/2, which was our base. So this works. To figure out our height, we need to find the height at each of those x values. So let's call the first height y0, the second one y1, y2, y3, and so forth, until yn minus 1, and then the last one y equals n, which is again the number of rectangles that we have. Alright, so if we were coming from the left, the height would be the first one, which is y0, and then y1, and then y2, and so forth, until yn minus 1. The height from the left does not include the last one, which is yn, because that's going to be the height from the right. From the right, you're going to start with yn, and you're going to come all the way back, but it's not going to include y0, because the height for y0 is the first one on the left. So again, from the left hand side, it doesn't include the last endpoint on the right, because that's not a left point. And the one on the right doesn't include the first left endpoint, because that's not a right endpoint. This is a listening check. Underline general formula. Underline general formula. Alright, so these are the heights. Alright, so let's take a look at the area approximation from the left, which is going to be base times height. You're going to leave a little bit of space because I'm going to add something onto this. So leave a little bit of space. And then the base, which is b minus a over n, times, because remember you factor it out, right? So you don't have to do each individual one. You can just factor out the half, in that case the base. So we can factor out the general base. And then we have just the heights added up, which starts at y0 all the way to n minus 1, does not include yn. And then from the left, it's base times height as well, leave a little space. We can factor out the base of it again, just like we did in our example here. We factored out a half because it's in every single one. And then the first height starts at y1, not y0, because it does include the left endpoint. So y1 plus y2 plus blah 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 to y minus n minus 1, and then it also includes yn. As a listening check, put a box around area approximation. The thinner the rectangles, the better the approximation. You can see the more rectangles we have, the less errors we have. Therefore, as the number of rectangles approach infinity, that will be your best approximation. So we're going to add to the general formula and say the limit as n goes to infinity, because basically the thinner your rectangle, the better it is. The limit as n goes to infinity for each one of those. Be a close approximation. That's pretty much it.